We continue with the primal dual relationship. Yes, as mentioned before, the two problems are closely related. If we have one solution, then we can find the other solution. Okay, so when do we use the dual? In an LP model, in which the number of variables is considerably smaller than the number of constraints, computational savings may be realized by solving the duals. This is because the amount of computation increase with the number of constraints at each iteration. So this is the formula how to find the optimal dual solution. Okay, you have the primal solution, optimal primal solution, and you want to find the optimal dual solution. So there are two methods. You can use either one. So if we say inverse or inverse matrix, we are referring to this. Okay, this one. It is the matrix and the columns under the starting variables. Okay, let's take a look at the example. Okay, so we have this problem. Okay, we have the primal and we have the dual. Okay. Okay, first, the first dual variable corresponds to the first variable in starting basic variable of the primal, and the second dual variable y2 correspond to the second variable in starting basic variable of primal r. So how do we know this? Okay, let's take a look at this. Okay, so usually this one, the first constraint, okay, the first constraint, we associate it to the first variable of the dual, and the second constraint, the second variable of the dual. Okay, so the starting basic here is x4 and xr. Okay, so x4, starting basic is x4 and xr. It means x1 0, x2 0, x3 0. So x4 we associate it to y1. Okay, the starting iteration, x1 0, x2 0, x3 0. So left is r, only r left. Then we associate it to y2. Okay, that's how it works. Okay, now we use the first method. Okay, first you need to, what is the starting primal basic variable? Okay, starting primal basic variables are x4 and r. Then okay, identify the z equation coefficient in optimal tableau. Okay, this is the optimal tableau. This is given. So the z equation coefficient means z row. Okay, in z row, the coefficient for x4 is 29/5, and coefficient for r is minus 2/5 plus m. Okay, so this one and this one. Okay, then We identify the original objective coefficient. Original objective coefficient. Okay. The original objective coefficient. We look at the standard form. Okay, standard form, the equation form. So 0 for x4, 0, and for r is minus m. Okay, so 0 minus m. Okay, so the dual variables, okay, as I explained earlier, y1 associated to x4 and y2 associated to r. Okay, then we can find the optimal dual values. Okay, optimal dual values here means for the dual problem, when the problem is optimal, the value of y1 and y2. The value of y1 and y2 when the problem is optimal. So the formula is you just add the second row to the third row. Okay, second row here, and third row here. So you get the summation. So you get this number, and this one, you get this number. Okay, so this is method 1. This is method 2. You just multiply the optimal basic coefficient. Okay, original coefficient of x2, x1 in the objective function. Why we put x2 first? Okay, because in the optimal primal basic variable, okay, in the optimal tableau, under the basic variable here, okay, we have x2, x1. So that's why we write it x2, x1. Okay, then we find the original coefficient of x2 and x1 in the objective function. Okay, the original. This means when you write the primal in standard form. Okay, x2, the coefficient is 12, and for x1 the coefficient is 5. So we have 12 and 5. Okay, 12 and 5. And then you find the inverse matrix. Okay, inverse matrix. Okay, optimal inverse matrix. Okay, inverse matrix is when the initial basic, starting variables, you find the matrix under the starting variables. The matrix under the starting variables are the inverse matrix. Okay, in this case, our starting variables are x4 and r. And so in the optimal tableau, the inverse matrix is this. Okay, so you multiply the two, then you get this matrix. So y1 is 29 over 5 and y2 is minus 2 over 5. Okay, if you notice, the duals are the... Okay, when the primal is maximized, the dual is minimized. So how actually it works? So when the other one is maximized, then the other one is minimized, the optimal solution actually is here. So you maximize this problem and you get this solution here. It's same as you minimize the problem here and you will get the solution here. So it doesn't matter which one is primal or which one is dual. Okay, so the rest of the slides you can just skip it. So that's all for this, for the dual.